Hi, everyone. Welcome back or welcome for the first time. My name is Ray McPherson. I am a research analyst at the California Housing Partnership. I've been doing data analysis using Python for 7 years. You're probably here because you want to learn how to automate analyses or clean up a big data set without relying on spreadsheet software. Today, I'm going to teach you how to create a Python script that does data cleanup and performs an analysis that answers a housing-related research question. First, we are going to set up a Python script that by doing things like importing packages, explaining workspaces, and accessing your files. Next, we'll talk about the research question that we're going to investigate and talk a little bit about the data that we're going to use. After that, we will get into some common data cleaning tasks, after which we'll do some data analysis, including how to create pivot tables. Finally, I'll show you how to write your data and outputs to Excel or CSV, and I'll give you a bonus project for you to work on your own. In order to get the most out of this video, you should already have a basic understanding of Python syntax and functionality, such as what variables are, what lists are, what a for loop is and how it works, and so on. This video assumes that you have this knowledge, and if you don't, you may find yourself not following along and feeling frustrated. You can pause here and go to the resources I've linked in the video description to do some tutorials that will help you out here. Remember that learning to code effectively is not something you can do in one day. You are learning a new language with its own rules in order to communicate with a computer that has a different way of thinking than you do. Take the time that you need here and be patient with yourself in the process. Once you feel that you have a grasp of the language, you can come back and resume this video prepared to say hello to the world of scripting. Additionally, in order to follow along with me, you should already have Python and your preferred IDE installed on your computer. You should make sure the packages we're using are installed in your local environment, and you should have downloaded the data that I've linked to in the video description. If you need help figuring out how to download Python, install packages, or install an IDE, refer to my video titled Building Blocks available through this channel on YouTube. By the end of this video, you will have the skills you need to create a basic Python script that will automatically perform a simple data task or analysis when it is run and write the output to a spreadsheet. You will also understand certain important scripting concepts, such as how packages interact with your code, and what hard coding is and why it should be avoided. Note that I am working off of a Mac, and while this should not have any effect on the content of the video, you may notice some of my applications look somewhat different if you are working off of a different operating system. I am also going to use VS Code as my IDE. You can use any IDE that you want, but note that some functionality and keyboard shortcuts may be different for you if you are using a different IDE. However, the content of the script will not change no matter which IDE you use, because an IDE only changes your experience writing and running code, not what the code itself has or does. So with that lengthy introduction out of the way, let's get started. Open up your IDE and create a new Python file by clicking File, New File, Python file. Save that file to your preferred location. I prefer to save my data in a folder that is neighboring or in the same folder as my data is in, because it makes accessing the data in the script much, much simpler. I'm going to save this as classdemo.py. By convention, this should be one word only. There should be no spaces. Wherever you save this code will become the workspace in VS Code. Make sure that your IDE interpreter is pointing to your cloned environment. So right click on, or just left click on your, on the bottom right corner, click on it, and then select your cloned environment from the dropdown. By convention, the imports come first in a script. Any packages that you need for your script will need to be imported before they can be used. However, any functions that are a part of the main Python language do not need to be imported in order to be accessed. For example, print is a command that is built into Python and you can type it in and run it right here. So let's give it a try. We're going to print hello world. We're going to run this by either highlighting it or just clicking next to it, right-clicking, hovering over Run in Interactive Window, and clicking Run Selection or Line in Interactive Window. Every IDE has its own shortcuts for running a line or a selection. The very first thing that you run might take a few extra seconds to run, but the interactive window will have popped up and you'll see in it that Hello World is indeed here and printed out for us. Now that you have your interactive window open, you can run code snippets directly in here if you want to test something out rather than writing it into your main script over here. For example, maybe you want to know what 20 divided by 3.5 is. So you type that in, you run it here, and it will do the math for you. All right, we are going to erase this because we don't need it. We're going to import a few libraries. Go ahead and type in import OS to your script. By convention, each import statement should be on its own line. That will make it look cleaner. OS is going to allow us to access files and folders on our computer. Type in import sys, which allows us to access the paths that our interpreter is using. On the next line, we are going to type in import pandas as PD. PD is the shorthand for pandas. It's the one that's conventionally used. If you ever Google something that pandas can do and you're looking at forums, people almost always call pandas PD. So this is a conventional shorthand, but you could give it any shorthand you really wanted. And this changes the name of pandas only in this script. It also makes for fewer keystrokes, so it makes it faster to type. Pandas is good for reading and analyzing tabular data. Next, we're going to type in import numpy as NP. Again, the conventional shorthand for numpy is NP. Next, we'll type in from pathlib import path. And this is case sensitive. Everything in Python is case sensitive, so make sure you get it right. What this import statement is saying is from the library pathlib, import only the class path. If you try to use other classes or functions from the pathlib library, you won't be able to because you only imported the path class, but it's all we need, so there's no need to import the whole library. Now that we have our import statements, let's run them. I'm going to highlight them and I'm going to use my particular shortcut to run it in the interactive window. And you'll know it's successful when the green check mark pops up saying that it is successfully imported these statements. If you encounter any errors at this point, you can Google the error message and probably find the answer, but most likely it's because you don't have the package downloaded or your interpreter is not looking at the environment where you downloaded your package. If you have downloaded Anaconda, it should have automatically downloaded all of these particular libraries for you. So it should not be a problem. All right, so let's access our data. I'm going to create two data variables, and these are going to be the file paths to my data folder and my output folder. I'm going to type in data path equals os.path.join in parentheses path in parentheses sys.path in brackets 0.parent comma data. Notice that I'm using some functionality from the OS, sys, and pathlib libraries here. So we're going to break this down a little step at a time. So sys.path is going to show me all of the paths in this sys that the sys library is holding for me for this particular working environment. So you can see here it's holding my code folder, it's holding the Python installations, and so on and so forth. what this is saying is get the first item in the sys.path list, which is going to be my code folder. So you can see it's the first item here, and it's the first item here. Remember that Python starts counting at 0, so the first item will always be 0. Now this part changes the path that I have selected down here into a path class from the pathlib library, which gives me access to the method called parent. So if I run this, it's going to give me the parent folder of the code folder. And sure enough, you can see it here. Python Workshops Workshop 2 is now the name that it's given. os.path.join takes the first part that we have here and connects it to the second part, whatever we have past this comma, which is going to be data. So now it's going to be looking at my data folder. So I have a code folder and a data folder that already exists. The code folder where I keep my code, and a data folder where I keep my data. So now this is giving me the path to my data. The next thing is going to be output path. And we're going to do exactly the same thing, except I want to point it to the path where my out data folder is. And that's what we're going to do right here. So this is the same thing, except it's pointing now to my out data folder. You can see right here. These folders should already exist. You can use OS to create a new folder, but that's not necessary here. So now we have run these. We are going to read in the census data, which you should have downloaded already, and put in your data folder. I've saved it to my data folder, so all I have to do is create a new variable. I'm going to call it pumsdf, and then I'm going to do pd.read CSV. Don't forget that PD is shorthand for pandas. Read CSV because the data is in a CSV file. I'm going to type in os.path.join, join data path to the actual name of the data spreadsheet. So it's called census data for workshop.csv. Don't forget to put the extension here, otherwise it's not going to read it. I'll run this. We can look at it, and it should look exactly the same as the spreadsheet you should have downloaded from me. So one thing to note here is we're using the data path and census data for workshop, this particular conventional way of typing this in. But we could, technically speaking, we could just copy in the whole entire path to our data folder, the whole entire path to our file even, and just put the whole thing right here instead of doing this way. And the reason why we don't do that is several-fold. First of all, if you're doing an analysis over and over again, year after year, or month after month, or whatever time frame, you may be saving your data and your code and your outputs to different folders. You may be moving things around. And so it's not always going to have the same exact path in your computer as it originally did. And so you would have to go and change every single instance of it. The other reason is maybe you want to go and share this script with one of your colleagues and have them run it. Well, the problem you can see here is this is calling on user/Ray, which is me. And if I share this with my colleague Sharon, and I say, hey, Sharon, will you run this? She's going to have to go and change every instance of Ray in this path to Sharon, assuming that we have access to the same folder. This is a Dropbox from a Dropbox folder, so we do. She was going to have to change this or change wherever she's keeping her own data set, et cetera, et cetera. What that is called when you just put in this whole line here instead of doing the way we did it, it's called hard coding. So it requires everything to remain exactly the same. What we're trying to do here is store it as a relative path. So as long as this code is stored in a code folder, the data is stored in an adjacent data folder, and the out data is stored in an adjacent out data folder, this will work no matter where or who runs it, and no matter how many times things get moved. So that is the basics of hard coding and why you should avoid it. It's especially problematic if there are multiple instances of a path in a script, which there can be, especially if you have a very, very big script. It would take a lot of time to make sure that you're getting the right thing, all of the right stuff changed. So now that we read the CSV, we see it here in this pandas data frame now. You can see how the data frame looks similar to the spreadsheet that I've given you. Another thing to note is that Read CSV itself comes with a lot of options here. And so does Read Excel. If you're using Read Excel, if you have a Excel spreadsheet, you would use the method Read Excel rather than Read CSV. And so if you type in a comma here, you can see a whole list of things that you can add as added keywords that will let you do different things to your spreadsheet before you even read it in. If you want to know a little bit more about it, you can even type in to Google pandas read CSV, and it will give you a lot more information from their website. Now that we've done that, let's talk about the research question that I've got in mind for us for this particular data. So my research question is this: how many households are there in ELI, VLI, LI, and moderate and above moderate income groups in San Francisco? And of those, what is the breakdown by sex and age? To answer the question, we are going to use census data. This is all census data. And I've selected PUM's 1-year census data because it gives me access to more variables and individual census records aggregated to the PUMA level. Now, PUMAs are public use microdata areas, and they may encompass multiple counties, or there may be multiple PUMAs in a single county, which is the case for San Francisco because it's very large. It has a lot of people. You'll need to know the PUMA IDs for San Francisco County, which fortunately I do. We need to know which variables we're looking for, so we utilize the data dictionary that's available on the PUM's website to select out the variables that we need for this. The other data that we are using is the HUD income limits for San Francisco. So the 2022 PUM's 1-year data set is what I've provided to y'all. You can download this data yourself from data.census.gov or using the download PUM's data.py script in the Dropbox folder that I've provided. Again, this is something I've already provided for you, so you don't have to. The HUD income limits are also in the Dropbox folder, but you could have gotten those from huduser.gov. I've linked both of those locations in the video description. So let's get into some data cleanup. So looking at this table, I can see that there are group quarters. Group quarters data still in this data set. I know this because the serial number will tell us if we're looking at a group quarters by indicating with the GQ or a housing unit indicated by an HU right here. And so we want to remove anything with group quarters because we're only interested in housing units. So I can do this by subsetting the table. I'll type in PUMS DF equals PUMS DF in brackets tilde PUMS DF in brackets serial number. Again, remember it is case sensitive. Dot string dot contains GQ. All right, so what's going on here? So we're saying from the PUMS data frame here, let's look at the serial number column. Turn that into a string. This is the next part here, and look for anywhere where the PUMS serial in the PUMS serial number column where it contains the string GQ. What the tilde is saying is not the tilde right here. So it's saying look for everything that doesn't, that's not GQ, that doesn't have GQ in it. This part right here is saying, with the PUMS data frame in the brackets, it's saying return the part of the data frame where this statement is true. So wherever GQ is not inside the serial number column, return that part of the data frame and reassign it to the PUMS data frame variable. So let's run it and let's look. All right, so we see here we went from 167,000 rows to 146, and all of these GQs are now gone. This is the pandas data frame remains in the same order every time you run it, unless you have intentionally changed the order yourself. So perfect. The next thing we want to do is get the part of the database that's looking at only the pumas that are within San Francisco County. So I have a list of those. So we're going to type out something similar to what we did just a second ago. So PUMSDF in brackets, PUMSDF. This time we're looking at the Puma column. And we're saying wherever that is in this list. So the list of Puma numbers is what we're going to put in here. And those are these right here. So all of these are the pumas that are associated with the San Francisco area, or San Francisco County. So again, what this is saying is from the puma column in the PUMS data frame, look for wherever the values that are contained in that column are in this list. So if they're in this list, we're going to return that part of the data frame where that is true. So let's run it and look. We've again dropped significantly the number of pumas that we're looking at. And we can see that the ones that are showing are only those that are in this list. So that worked exactly how we needed it to. So one thing to keep in mind is that when you're, for instance, looking at Excel and you want to filter something out so that you can't see it anymore, like if you only wanted to pick certain variables from a column, then you could definitely do that, but all it's going to do in Excel is hide them for you. What this does is actually deletes them or removes them. So keep that in mind that these are deleting the other data. Not permanently, it doesn't affect the underlying data. The Excel spreadsheet is still exactly the same. All right, next, let's get rid of the columns that we don't need. So I'm looking at this and I see we have an unnamed column right here. Over here, we've got state X, state Y, and another column called SP order. I don't need any of these. So we're going to get rid of these by using the drop method. We're going to type in pumsdf.drop. We're going to tell it that what we're trying to drop is columns. We're going to give it a list of the columns that we want to drop. So the first one is unnamed 0. The second one is called state X. Third is state Y. And finally, SP order. Then we're going to give it a keyword that's called in place. We're going to assign that to true. So what in place does is it keeps us from having to always reassign the variable back to itself. It just does this for us in place. So it's going to do this automatically within this line. It's actually going to drop those columns for us. Now you can ignore this part right here. It's just a little warning and it's not going to affect our ability to do what we're needing to do. So you can see it's dropped the columns that we don't need. Now we're going to look at this data frame again and see that the sex column here, instead of having male, female, has just some numbers, 1s and 2s. And the regular person isn't going to know what that means. And it's kind of hard to keep in mind. So we're going to actually change it so that it's, instead of 1s and 2s, we're going to have male and female. The PUMS data set doesn't record at this time anything besides male and female. So all the sexes are either male or female. We're going to type in PUMSDF sex in brackets. So it's saying, okay, look at the sex column. And we're telling it to replace, because we want to replace the values, the 1s and 2s in here, with male and female. So we're going to use the replace method on the sex column. We're going to feed it a dictionary. And a dictionary has key value pairs. So the key should be the value that's already inside of the column. And the value should be whatever you want it to change to. So 1 is already in there. We want it to change to male, because I know from reading the data dictionary that 1 is male and 2 is female. So that's what we're going to feed it. and we're going to say in place equals true again. So in place equals true is available on many of the pandas data frame methods, but not all of them. We're going to run that, check it out, and it does indeed show the 2s are female, the 1s are male. So perfect, it did exactly what we wanted it to do. All right, so at this point, I've used lists, dictionaries, we've imported libraries, we've done some built-in functions. If any of this stuff is feeling unfamiliar, please go to the resources that I've linked in the video description and refresh your memory on different basic elements of Python, especially if you're feeling confused, especially if you're feeling frustrated, if you're not sure what a string is, if you're not sure what integers are and floats are. This would be a really good time for you to go back and refresh your memory and then come back to this video in a better state of mind. All right, so if you're still here with me, let's do something similar to this, but we're going to do it for tenure. So tenure is this column right here that's called 10. I know from reading the data dictionary that 0s are vacant, 1s and 2s are owners, and 3s and 4s are renters. So I want to change the tenure values again to something that's actually human readable, but I'm going to use a slightly different methodology than what I used before because it has 5 unique values. So I'm going to use NumPy, and I'm going to use a method called select. But first, I need to build 2 lists. The first one is conditions. I'm going to call it conditions. The second one I'm going to call choices. And these we're going to feed into the NumPy select method. So conditions should have all of the conditions that you're looking for, and choices should have all of the things you're trying to replace that condition. So I know that whenever tenure is equal to 0, that means it's vacant. So because this is the first element, this condition is the first element in this list, its associated answer, its associated choice should also be the first element in the next list. That's very important. Next thing I want to point out is that equals equals here is triggering a Boolean, which means is equal to. If I wanted to do is not equal, I would do exclamation point 0, do also less than or equal to, greater than equal to. And those trigger Booleans, which are true or falses. So it's saying if it's true that tenure is equal to 0, then rewrite it as vacant. The next one is if tenure is equal to 1 or 2, or in the list, 1 or 2 rather, then we want it to be called owner. And finally, if tenure is in the list 3 or 4, then make this renter. Okay, so now we have our conditions, we have our choices, and we are going to use NumPy select, but first we have to tell it which column we are trying to modify or create. So we're trying to modify the tenure column so that all of these numbers change to actual words. We're going to say make the tenure column equal to whatever comes to the right of this. So make it equal to numpy.select. We're going to feed it conditions, our conditions list, our choices list, and we're going to tell it a default. Use the keyword default equals np_nan. So the default is what's going to occur if any of these conditions are not met. So if there's a number that's not 0, 1, 2, 3, or 4, then it's going to give us a different alternative. So the default is np_nan, and nan stands for not a number. This is going to show up as a blank in the Excel spreadsheet or the CSV spreadsheet, and that's why I like it, is because it shows up as a blank, as in there is not a value there. So let's run this. It seems to have worked. Yes, so the renters 3s are renters, 1s are owners, and you can see that reflected here. Okay, so we're going to subset again because I just realized I only want to look at renters. That's what's most interesting to me and to my organization. So we're going to subset this out again, and you should know how to do this because we did it earlier. But we're going to use actually a different methodology because I want to introduce you to something, a method called LOAP. So using the using the pandas data frame methodology LOAP, which allows us to look for where a condition is true. It stands for locate. It locates values where in a specific column or index, it allows you to just return the part of the database where where the condition is true. You can also use it to modify values in a column based on a condition. So for now, we're actually just locating values. So I'm looking for, oops, in brackets, wherever PUMS in the tenure column of the PUMS data frame, it's equal to the value renter. I only want those. So I'm going to run that. Oops. Sorry. And we see 2,000 rows have returned as opposed to 3,900, and they're all renters. All right, so for the last part of the cleanup, let's turn the householder age here into a categorical set of values instead of just a numerical one. We want that because we want it to be in different groupings, age groups, in order to make this easier to view when we view this as a pivot table. So we're going to use a method of the pandas data frame called cut. So we're going to type in, we're actually going to create a new column called householder age. And we're going to assign its value to the results of PD cut. We're going to tell PD cut which column we want it to look at. So we want it to look at the householder age, this column right here. We're going to tell it what bins to make. So these are the categories, the lower and upper limits of each categories. I know from reading the census data that a householder is no younger than 15, so the very lowest number should be 15. The next bracket, the upper limit of the first bracket, I want to make 24. The next upper limit, I want to make 44. Next, 64. And the last one, I want it to capture everything above 64. So I'm going to put float in parentheses infinity. Now, practically speaking, the people don't live over like 120. So I could just put 120 here, but I want to capture everything just in case there's been mistakes in the census, which should have been caught, but if they weren't, I'll be able to tell. And then finally, we'll have labels here. So the labels are going to be what I want these bins to be labeled. So the first one's going to be 15 to 24. Second, 25 to 44. Third is 45 to 64. And last is 65 plus. And you'll notice that there is one fewer label than there is bins because you have a lower limit and then all of the upper limits here. Whereas this is just capturing the lower upper limit altogether. So there should be one fewer. So let's run this. Let's look at it. Scroll over a little bit and we can see, yep, 25 to 44 is the householder age here. The original age was 42 and it sure does belong in this one. 70 is sure enough older than 65. 35 is older than 25 to 44. So perfect. It did exactly, or is within the 25 to 44, excuse me. So perfect. It did exactly what we wanted it to do. Cool. So now we've done a bunch of data cleanup of the census data. We're going to start getting into the actual analysis. So we're going to see what all of this cleanup is for. But first, we're going to mess around with the income. And by mess around, I mean make it what it needs to be. So the income for every household is listed right here as household income. The census provides an an inflation adjuster right here. And so we need to times these two values together in order to get the inflation adjusted household income. So we're going to make another new column, and we're going to call it adjusted HINCP. We're going to make it equal to the value of the HINCP column times the adjusted income column. These are going to come out as currency. It's in US dollars. So I'm actually going to use the round method on it. So I highlighted it. I put parentheses around it. I'm going to use the round method that's built into Python. And I'm going to also tell it to only give me 2 decimal places since currency only has 2 decimal places. So I'm saying round the output of this math to 2 decimal places. Let's run it and see. All right, yeah, you can see that there's 2 decimal places for each of these, and they sure do correspond with the exact right times. And one thing that you'll notice is that it does only multiply this by this, so it multiplies row-wise instead of doing it in a random haphazard way. So that's should be comforting for you folks. All right, the last thing we need to do with the income is that I know from reading the census that the household income, if it's less than negative 60,000, it's not a real number. And so negative 59,999 is the lowest amount of income the census allows. So we're going to change anything smaller than that to 0. So earlier I told you that you can use the loc method and you can change a value based on a condition, and that's what we're going to do here. So I'm going to type in hums.loc. We're going to look at the household income because that's where it should have the values that are less than or greater than negative 60,000. So I want to look for where the value of that column is less than or equal to negative 60,000. In order to keep it an integer here, you need to make sure that there's no commas. Then do a comma and type in adjusted household income. And out here, make it equal to 0. So what this is saying is look in the household income column, wherever it is less than negative 60,000, you're actually going to change the value of the adjusted household income column. So we're looking at this column, but we're changing the value in this column. We're changing it to 0. So wherever this condition is true, change the value in this column to 0. This is going to overwrite whatever is already in here, so keep that in mind. So we're going to run it and look, and there we go. We've got the output here. You won't see any big difference because we don't have any of the negative 60,000s showing up. But one thing you can do to check this is you can look for this right here. We can actually go into our little interactive window here, and we can look for where the value of the HINCP column is less than or equal to negative 60,000. Well, it was already empty, it turns out. So there was no values that were extraneous. At least we know that now, but this is a good thing for you to know anyway. So it didn't change any of the values. You could also actually save this spreadsheet out to an Excel spreadsheet so that you can look at it physically if you want to do some checks by yourself as we're going along. And I'll show you how to do that right here. You can do humsdf.to Excel. In parentheses, you're going to type in os.path.join. Remember, it joins 2 parts of a path together. We're going to give it the name of our output path variable, and we're going to put in quotation marks the name that we want to give to the spreadsheet. So we're going to call it checking hums.xlsx. Make sure you put the extension, and since it's to Excel, you could do to CSV just as easily. But since it's to Excel, you need it to have XLS or XLSX. And then you can run that, and it will put that data in the output folder for you, and you will be able to check it yourself. All right. So we got that all taken care of. Now we can finally make our income groups. So we're going to make a new column called income group. Oops. Income group. We're going to use PD cut again because we want to take the adjusted income variable and we want to turn that into income groups. So we want to make an extremely low income group, a very low income group, a low income group, and a moderate and above income group. I know from reading the HUD income limits what the upper limits are for each income group for a 4-person household in San Francisco. So I know that for ALI, it is 55,900, for VLI, 93,200, for LI, 149,100, and anything above that is going to be moderate and above income. So now that we know what our bins are going to be, what our thresholds are, we're going to use the cut method of pandas to make that happen. So we're going to use the adjusted income, and we are going to tell it to make the bins equal to this list. So the lower limit, as I've said before, is 59,999. The upper limit for ELI is 55,900. Upper limit for VLI is 93,200. Upper limit for LI is 149,100. And finally, anything above that, which we'll capture with float infinity, is going to be captured there. Now the labels, of course, we have already said it. We want ELI, VLI, LI, and moderate above. So let's run that, see what happens. Here we go. We got our income groups. You can see that 111,000 is indeed less than 149,100, and so it does belong to LI. And you can keep checking these on and on if you like. Okay. Finally, we have everything we need to make a pivot table. So drum roll, please. We're going to make the pivot table, we're going to assign it to a new variable called summary table because we want to keep the PUMS data frame itself intact. And we are going to put pd.pivottable. So pivot table is the methodology of the pandas data frame that will create a pivot table for us. We're going to tell it to look at the PUMS data frame for the data. We're going to tell it the value that it should be looking at is WGTP. So this is, if you're looking at Excel, when you're making a pivot table, the value that it's asking for is exactly the same as the values keyword here. We're using WGTP, this one, because it is the weighted variable the census uses. So for every line, one line is one household, but the weighted variable tells us how many households are like that household. So this might be one household, but the census says that 66 households are equivalent to this household. And so to get the number of households, the true number of households, we have to times or sum everything together. So we have to sum up the WGTP weighting variable. All right, next thing we're going to do is tell it the index. So the index is equivalent in the Excel pivot table to the rows. And this is going to be sex and householder age. So there's going to be two indices. The next thing we're going to tell it is what columns we want, and we want that to be income group. So each income group will be one of the columns. Let's see what that looks like in a second. Next thing we're going to tell it is what we want the aggregate function to be. So we're going to tell it to use sum. We want it to sum, but you could use average, you could use divide, you could use whatever. We're going to tell it to make the margins happen. So margins equals true. We'll create margins, which are the totals of the rows and the columns, the total values. We're going to tell it what we want those margins to be named, which we want to be named total. Finally, you've got all of this. We're going to run it. And here you go. You have something that looks almost exactly like a pivot table that you would get from the Excel pivot table. So you can see that there are 3,058 ELI households that are headed by a female between the ages of 15 to 24, and so on and so forth. So that's really super cool. Now imagine one of the things that you can do in Excel that you can't do as easily here is that you can use a filter where it allows you to filter some of the rows out based off of a preference. Imagine you wanted to do that here. You have to do it a little bit more of a complicated way. You could create a pivot table that you initialize that's going to look exactly like this one. So we're just going to copy and paste it. We're going to call it summary table F. And instead of feeding it the whole data frame here, you can just feed it the part of it where the sex is equal to female. But of course, don't forget that if you want to do that, you have to wrap this in a bracket and use pums dataframe.load. So you could do that. Sorry, I spelled this wrong. And you'll see it gives you exactly the same table as up here, except all you have is the females. Now we don't need this, so I'm going to delete it. You could also just subset the table you already have using loc. So you could do summary table dot loc. So one thing to note here, I'm going to show this again. One thing to note here is that you have created two indices, one for sex and one for householder age. That means that these are divided into summed by two different rows. So each row grouping is called an index, and the indices are also level. So level 0 is sex and householder age is level 1, remembering that Python starts counting at 0. So when you are trying to locate a value in a specific index, especially if it's a multi-index, you have to wrap the index variables or values rather in a tuple. So we're going to tell it that we want to look at the female value from the first index. And from the second one, we actually want all of it. We want all of the values because we want to know all of the ages. So we're going to tell it slice none. So it's not going to slice that for us. It's just going to show us everything. Then outside of the tuple, you're going to put a comma, and then you're going to use the colon. And what this is doing is the comma says, okay, we're done looking at the rows. Now I'm going to tell you what columns we want. And we want to look at all of them. We want ELI, VLI, LI, moderate, above, etc. So using a colon here is going to allow us to look at all of them. So if I run this, you see exactly the subsetted thing. The only difference is that up here where we made a separate table, this has a total and this one doesn't. So it's only subsetted out the female portion of this. Another thing you can do is, because the tuple is a little confusing, is using loc, you can put in summary table, look at the index, so dot index, and you're going to tell it to get level values. And you want to look at the first level, which is female, or the first level, which is sex, and it has female, male. You're saying where the level values in level 0 equal female, give me that part of the data frame. And it looks exactly the same again. So these are a couple of handy ways to sort of filter things out. This didn't save permanently because I didn't assign it to a variable. So if you look at a summary table, yes, it looks exactly the same as before. Now, in one of the biggest differences you might notice biggest differences that you might have noticed is that the first level doesn't have subtotals, which it would if we were doing the pivot table in Excel. So we're going to do that. We're going to insert some totals, some subtotals up here, so we can know how many females there are total and how many males there are total. So the first thing that we need to do is reset the index. So we'll use the reset index method. We're going to say in place equals true. What that's going to do is turn the rows back into, the indices back into columns. So you'll see instead of those being like down here and away, they're now up here and in line with the other columns. So we've done that. And the next thing we're going to do is a little bit complicated. So I ran into this problem where I wanted to see subtotals and I wasn't sure exactly how to do it. So what I ended up doing was Googling my problem, coming up across some forums, and finally this code snippet that looked similar to this. And I just changed it around a little bit in order to work better for my own particular code. And I use it all of the time now. So this is something that you might end up doing yourself, is going and looking on forums if you have a problem that you can't solve, finding snippets of code and adjusting them to work for you. That's what happened here. So the most important things are you should have your row groupings in these brackets here, this one and this one. And the second important thing is that when you have a range, when you're looking at the range here, it should have one more number than the number of elements in each of these lists. So there's 2 elements in each of these lists, so then your range needs to be to 3. So let's run this. And what this is going to do is it's going to add, it's going to add subtotals, and you can see them right here, except that it's not named subtotals. And I know that's how it is in Excel, but I prefer to have a name there. So I'm going to rename the blanks into subtotal, into the word subtotal. So we're going to use the rename method. I'm going to tell it to rename the index. Again, key value pairs. So where it has no value, which is represented as just empty quotation marks, change that to subtotal. And then we also have to tell it what level it is, because there's 2 levels again here, because the summary table, this little thing that we did here, reset the indices to be sex and household or age. And we need those levels to be at level, or we want it to look at level 1. And here we go. We've got subtotal here, and oops, we've got duplicates here. So this is a factor of how this part works, is it totaled everything. So now it's got a duplicate, we have to drop it because I don't want to have an extra duplicate in here. It looks ugly. So we're going to use the drop duplicates method. We're going to tell it to look wherever the total value is. Look for a row, the row that is equal to total. That's what this is saying. And if it's a duplicate, I want you to drop it. If it has duplicates, I want you to drop the duplicates. We're going to do that in place equals true. So let's see if that worked. Reminder that this has to have every value has to be exactly the same. This index, actually, if you save this out into Excel, you'll see that it has total here and total here. It just doesn't represent it the same. It doesn't like to duplicate it in Python, but it knows that it's a duplicate, if that makes sense. So anyway, it knows that every single element of this line is the same as this line. And so let's make sure. Did it drop it? It sure did. So now we've only got 1 of those rows instead of 2. All right. I don't like that the subtotals are all on the top. I know that that is how it looks in Excel, but I don't like how that looks. So what I'm going to do is I'm going to shuffle this around so that all of the age groupings go above the subtotal. And this is a really good method for you to know anyway, because a lot of times this stuff shows up as alphanumeric in alphanumerical order when it's sorted, and that's not necessarily how you want things sorted. So I'm going to show you how to use the reindex function, reindex method equals summary table dot reindex, and give it a list of your row values, and then tell it what level you're sorting, reindexing on. So it's level 1. Again, we're only looking at this one. We like the females on top and males on bottom. It doesn't really matter to us for that. So this is only going to resort this. If you put an element in this list that actually doesn't belong in here, it's just going to not show up. So if you miss something, if you miss 15 to 24, 15 to 24 is just not going to show up in your little reindex here. So make sure you get it right. And here we go, 15 to 24, 25 to 44, 45 to 64, 65 plus, and subtotal. That's how I like it to look. All right. Now, just for funsies, imagine that you want to know what proportion of each sex and age group belongs to each income group. Because you're looking at this and you're like, okay, these numbers are great, but I want to know the proportions, the percentages. So we can find this out by making a for loop. And it's going to look through every column in the pivot table. And we're going to type in for column in summary table dot columns dot to list in brackets to -1. All right, so let's break this down. So for column, so this is the iterator, the column, this word here is the iterator. You could call it anything, but I want to make it clear that we're talking about a column here. So it's going to look through, so for each column in the summary table, which is this, columns, which are all of these, ELI, BLI, LI, etc. Turn those columns into a list. And out of all of the values in that list, look from the first to the second to last one. So this is saying everything up to -1. This is -1 here. Don't include -1 is what this is saying, in other words. So for each of those, because if you divide total by total, it's going to total 1. We don't need to know that. We know that total divided by total is 1. So we're only going to do the math on these 4. All right. So what we want to do is for every bit of math we're doing, we want to assign the output to a new column, and we're going to put the name of that as %_ plus column. So what this is going to do is for the first column that it looks at, which is going to be ELI, it's going to call the next column, that column, %_ ELI. For the VLI, it's going to be %_ VLI, and so on. We're going to assign that to the result of this math. Summary table column divided by summary table total. So this is saying, okay, the first one is going to be ELI, divide that by total. The second one is going to be VLI, divide that by total, and so on and so forth. So that's the math that you're going to do here. But we don't want it to just be the proportion. We actually want it to be the percentage. So we're going to times that by 100. So ELI divided by total times 100 is going to give us the percent of ELI households that are in this age bracket, essentially, age and sex bracket. But what's more is we want to round this again. And we want to round it to 2 decimal places because that's what looks nice to me. So we're going to do round to 2 decimal places. Okay, so now we got this ready to go. Let's run it. Because it's a really small data frame, it's going to run really fast. And you see it here, % ELI, % BLI, % LI, etc. And you can see here that 44% of female-headed households aged 15 to 24 are ELI. And only 16% are VLI. Only 15% are LI. 24% are moderate and above. But the vast majority are ELI. And so now you can look at these numbers and you can really start looking for patterns and perhaps start asking why these patterns emerge. For instance, why in both male and female groupings are the youngest and the oldest households the most vulnerable to being ELI? So we can really start to try and dig into that understanding here. And just as a reminder, when we're talking about ELI households and we use the 4-person household income groupings, to be extremely low income in a 4-person household in San Francisco, you have to be making less than $55,900 a year. So 44% of these people in this grouping are making less than that much. So anyway, the last thing you might want to do is save this out to an Excel spreadsheet. And I showed you how to do this earlier, but if you want to have this saved into your script itself, you need to put it into your script, into the script itself. So summary table to Excel, oops, not to clipboard, to Excel. We're going to do os.path.join, output path, and we're going to give it a name. We're going to call it income groups SF. And don't forget to give it XLSX or SLX. You can give it a sheet name here if you want. You could say the sheet name is equal to sheet 1. You could say index equals false if you don't, well, you shouldn't do that for the summary table because then it will remove the female and the male rows, but you could do that, etc. So there's a lot of keywords you can add in here. So you can save that out, and you can save out, I personally like to save out the data set that I have been working off of, the PUMS data frame, especially if I've made adjustments to it, because I might want to mess again with it in the future and I don't want to have to redo everything, even though it'll only take a few seconds because I've got it all saved in this code. So I'm going to save it to Excel, and this also makes it so that other people can look at it and make sure that I haven't missed anything, that the math looks right. So I call this cleaned data XLSX. If you want to save this as a CSV, you sure can. It's just 2 CSV instead of 2 XLSX. And you can give it like the separator that you want to use, like a comma, which is the default, so you don't have to add it in, or tab, or whatever. Okay. If you all want to try a project on your own, having gone through all of this, you can do a similar project to this, but instead of using the income limits for a 4-person household, create income groups based off of the household size itself. So the household size is represented by the variable NP, which stands for number of people. So you're going to use both the household income and the number of people to determine the income group. And then make a output that looks just like the summary table here based off of that. So the output table is going to look exactly the same. The only difference is going to be the numbers that you're going to get. So if you want to try this on your own, you absolutely can. I have included in the Dropbox folder an answer sheet, like the code that I used to create it, to create the answer sheet, and also the answer sheet in the data folder. So if you want to try your hand at it, you're coming up on problems, you can definitely look at the answer sheets and the answer code and get some ideas to help you out here. If you have any big burning questions, have any comments or anything, please add it to the add a comment to the YouTube video, or reach out via email, or whatever you feel the need to do. So I appreciate you all being here. I appreciate you all taking the time to sit with me through this demo. And if you have any other thoughts about what you'd like to learn about, if you want to know something more about data cleanup, something more about analysis, maybe something a little more complicated, please comment in the video and I will look through them. I will answer your questions and answer comments as best as I can. And maybe we'll make another video one of these days. So thank you so much. Have a very good rest of your day.